Greetings and good day. The topic given to us was delineation of hydrocarbon potential at reservoir X using AVO analysis. I am Bhawatarani and I'll be covering the introductory part of the literature review. The AVO or amplitude variation with offset technique measures differences in amplitude of seismic reflection with changes in distance between the shot points and the receivers that indicates differences in lithology and fluid contents in rock above and below the reflector. Analysis of AVO helps geophysicists to better assess the reservoir rock properties such as thickness, porosity, density, lithology, and fluid content. As seismic waves travel through the Earth, they encounter layer boundaries with velocity and density contrast. The energy of the incident wave is partitioned at each boundary. Precisely, part of the incident energy associated with a compressional source is mode converted to a shear wave. Both the compressional and shear wave energy are partially reflected from and partially transmitted through each of these layer boundaries. Analysis of reflection amplitudes as a function of incidence angle can often be used to detect lateral changes in elastical properties of reservoir rocks. This may then suggest a change in the ratio of P wave velocity to S wave velocity, which in turn may imply a change in fluid saturation within the reservoir rocks. Effective AVO analysis needs special processing of seismic data and seismic modeling to assess reservoir rock properties to model other types of fluid content with a known fluid content. A gas-filled sandstone may exhibit increasing amplitude with offset, while a coal may exhibit decreasing amplitude with offset. A disadvantage of AVO analysis using P wave energy alone is its inability to produce a unique solution. So, the results of AVO are vulnerable to misinterpretation. The inability to differentiate a gas-filled reservoir from a reservoir with only partial gas saturation is one common misinterpretation. AVO analysis is more successful in young and poorly consolidated rocks such as those in the Gulf of Mexico than in older and well-cemented sediments. Today, traditional AVO is almost exclusively incorporated in the seismic inversion. Inversion of data, which is the conversion of reflectivity to layer-based rock properties, is almost always based on AVO principles. To start with, the Zioprins equation allows us to derive the exact plane wave amplitudes of a reflected P wave as a function of angle, but sadly it does not give us an intuitive understanding of how these amplitudes relate to the various physical parameters. Over the years, a number of approximations to the Zioprins equation have been made. The first was by Bottfell in 1961. The Bottfell approximation was further refined by Richards and Frazier in 1976 and by Archie and Richard in 1980 respectively. The Richard, Archie and Frazier approximation is appealing because it is written as three terms. The first involving the P wave velocity, the second involving density, and the third involving S wave velocity. Then, Smith and Gitlow in 1987 gave another approximation based on the Archie and Richard equation. Rutherford and Williams' classification of the reflection coefficient curves has become the industry's standard, and it is associated respectively with the 1970s classification of bright spot, phase reversal, and demout. The classification was developed for reflections from hydrocarbon saturated formations. According to Rutherford and Williams' classification, the slope of the reflection coefficient curve is negative for all classes. The reflection amplitude decreases with the angle of incidence. However, the absolute amplitude can increase with angle of incidence as depicted for class 2 and 3 AVO gas saturated anomalies. In 1997, there was an extension of this paper by Castagna and Swan where they cross-plotted the AVO attributes.
Hi, I'm Rishika. I would like to talk about the amplitude versus offset modeling. Before I go through the main part, I would like to talk about the review on the history. On 1984, Ostrander developed amplitude versus offset AVO method. Followed by Smith and Gitlow on 1987, they developed a methodology to identify fluid content in reservoir through anomalies on seismic data. Then, on 1995, Worm and Hitlerman developed cross-plot method of intercept versus gradient for fluid anomalies identification. And then backtrack on 2006. Identify the characterization of sediment by three parameters, which are bulk modulus, shear modulus, and bulk density for AVO modeling. Moving on to AVO modeling fundamentals, first I would like to talk about the rock physical properties, which are basic rock properties includes P wave velocity, S wave velocity, density, P and S impedance, Poisson ratio, and VPVS ratio. For the modulus rock properties, there are bulk modulus and shear modulus. And for the anisotropic rock properties, that is directionally dependence on seismic velocity. For petrophysical rock properties, it includes minerals, porosity, and water saturation. It also needs to derive the effective porosity and total porosity, and need to know the fluid type, gas and oil ratio, oil and gas gravity, brine salinity, and also need to know the temperature and pressure of the fluid. For the empirical relationship, as we have learned, there are many types of equations and relations. First, I would like to talk about the Willis equation, which works best for the water saturation rock, consolidated rocks, and high effective pressures. Second is for the Hans relations. Hans relations works best for clay content and muds. For the Castagna's relations, it is used to predict the shear velocity from the compressional velocity. For the Greenberg-Castagna relations, it is used to estimate the S wave velocity from P wave velocity in the mixed lithology, brine saturated rocks. And lastly, for the Gardner relations, the Gardner is used to predict the density from the compressional velocity. Moving on to the AVO equation, which is Zopritz's equation, used to derive the plane wave amplitudes of a reflected P wave as a function of angle. It is also described the relation of incident, reflected, transmitted, compressional shear wave at an interface of isotropic media. For the AVO attributes, there are two types, which is intercept gradient and Poisson's ratio change. Intercept gradient is calculated from pre-stacked seismic data to identify the AVO classes. We can identify the AVO classes by knowing the positive and negative AVO. For the Poisson's ratio change, it also indicates the presence of gas-saturated sediments. Poisson ratio change also can identify the compatibility between gas-saturated sand by calibrating the changes of Poisson ratio with resistivity, VPVS, and gamma ray logs. Next is AVO crossplots. The diagram on the left shows the AVO crossplots. AVO crossplot is to derive the relationship between different variables. The plotting in the diagram shows the AVO intercept attribute on the x-axis and AVO gradient on y-axis. So the positive AVO represent the pre-stack energy increases domain, and the negative AVO represent the pre-stack energy decreases domain. So based on the diagram, pre-stack energy decreases is the quadrant 1 and 3, and pre-stack energy decrease is the quadrant 2 and 4. And then for the AVO modeling, the diagram on the right shows the AVO modeling, which already generate the synthetic stacking.
Good day, my name is Arvin. I'll be talking about fluid substitution today. Fluid substitution plays an important role in AVO modeling. It is an essential step in seismic attribute analysis. Besides AVO modeling, fluid substitution also plays a role in reservoir fluid characterization, lock correction, and also reservoir monitoring. So what does fluid substitution do is basically helps us to understand and allow seismic responses of a rock during a pore fluid changes. So one with fluid substitution, Gasman theory is widely used. This is stated by Mr. Hong and B. Deutsch. Gasman theory allows us to generate seismic responses based on changed elastic rock properties resulting from various reservoir rock conditions used in order to estimate the changes in P wave velocity, S wave velocity, and also bulk modulus. Below are the model assumption of Gasman equation. The first one will be rock is homogeneous and isotrophic. Second one is rock is considered connected with high porosity. Third is elastic stiffness and which are relatively unlarge, and finally with low frequency seismic. So what we have here is the Gasman equation, whereby K asterisk means tri-frame bulk modulus, Km means mineral matrix bulk modulus, KFL means fluid modulus, KSAT means saturated bulk modulus, and Phi means porosity. So next we have the synthetic generation. So basically synthetic seismogram requires a stratigraphic model with the aid of P velocity, S velocity, and also density. The purpose of this synthetic generation is to identify the seismic reflections in the data. A synthetic seismogram is a fundamental link between well data and seismic data. So basically, geophysicists, they are able to create a synthetic generation using specialized software such as Petrel and Hampson-Russell. Now for users to create a synthetic seismogram manually, these are the following steps. First is to edit the sonic and density log for bad intervals, and then they have to calculate the vertical reflection times, and followed by calculating the reflection coefficient. Fourth step, they have to combine the last two items, which is the vertical reflection time and reflection coefficient, to create a reflection coefficient time series. That means it's a compound of those two things. And finally, they have to convolve the reflection coefficient series with the wavelet.
As a conclusion, AVO modeling and analysis can predict reservoir properties such as porosity, density, lithology, fluid content, and also rock's elastic properties through its attributes. It is used to delineate and characterize the lithology and fluid effect also. AVO-based attributes are excellent indicators for identifying the hydrocarbon containing sand phases. So that's all from us. Thank you for listening.